There we go. All right. So before we get started, I just wanted to do a quick reminder that your written assignment is due tonight. So hopefully you've already been working on it and maybe even submitted it already. If not, you have until midnight tonight to submit. So that is going all through Moodle. So just make sure that you save it as a PDF. Otherwise, I don't think it'll allow you to submit. I do find that quite a few students sort of panic at the last minute because they forgot to save it as a PDF. That will solve most of the problems with uploading. What was the other thing I wanted to say? The next thing was I have the midterms graded. I came in this morning and did it. I ran into an issue trying to figure out how to use the, what do you call them? The Scantron sheets. So the first couple that I graded wrong, and then I had to sort of come back and try again once I figured it out. And then the place was closed over reading week, so I had to come in and do it this morning. So that's why we didn't see it as soon as I had wanted to, but I've sorted out all of the kinks, so I should be manually uploading those tonight, so you can see them tonight. So if you've been waiting for that, that's why. It's sort of one of those things where I think everything's going a little bit off today, but that's neither here nor there. All right. Okay. So before reading week, we had been talking about memory and different parts of memory, and mostly we had focused in on our sensory memory. And then we started delving into immediate memory, but we didn't get too far. So I think it's a good point to start here with a nice diagram that shows us all of the concepts we've been talking about, as well as how they're going to relate to some of the other concepts that we're going to introduce today. So on the surface, this is kind of an awful looking diagram. There's lots of arrows, lots of information here. But if we break it down, it actually sort of flows and does a good job representing a lot of things in one place. So we have, at the very beginning, we would have our sensory input. So things coming in from our sensory receptors, information from our eyes or our ears or whatever. And that's going to come into our sensory memory. So you remember our sensory registers, either iconic registers or echoic registers, things that would take in sort of visual information or auditory information and allow us to hold that information very, very briefly. And that's that moment of, wait, what did I just see? Or what did I just hear? And if we choose not to pay attention to that information, if it's deemed irrelevant, we can immediately forget it. So we have forgetting at each of these stages here. So information can be lost at any stage. But if something in our sensory memory is deemed worthy of attention, we can then bring it into our immediate memory. And so we talked about immediate memory as being a fancy term that combines short-term memory and working memory. So anything that we're holding on to sort of temporarily. And so if we've paid attention to something, we're bringing it into our immediate memory. We can either do something with that information. Maybe we can recite back what we just heard. Maybe we can dial the phone number that we're holding on to, or we could forget. And if we want to prevent forgetting, we can use rehearsal. So we can repeat that information to maintain it in our immediate memory pretty much forever. As long as you spend time and effort and attention holding it there, you can hold it as long as you can be bothered to hold it. So that's stuff that we've already talked about. But next we're going to be talking about how we get information into our long-term memory through the process of encoding, and then how we pull information back out of long-term memory through the process of retrieval. And this concept of encoding and retrieval is actually going to be really important when we get into the distinction between our short-term memory and our working memory, both of which are falling under that umbrella of immediate memory. And so most of what we've talked about so far has been talking about immediate memory has been talked about in terms of short-term memory. So we've said that this is information storage where we're going to hold on to information for a very short period of time. And so we talked about the fact that it has a duration of about 20 seconds. So after 20 seconds, if you haven't been actively rehearsing, you can forget that information. And you have a span of about 7 ± 2 digits. So our digit span is somewhere in that range, depending on how functional your memory is. And in that sort of short-term storage, we can have information coded as visuals. So we can have images that we've seen. So maybe you're looking at something and you want to remember exactly what it is you're looking at, so you can think of that image. We can have a phonological memory, so sounds. If someone tells you a phone number, you can sort of hear in your mind whatever that sounds or that sound is. Semantics, we can have the meaning of those things. So maybe you don't want to hold on to sort of the specific tone that someone was using while telling you something. You just want to remember the meaning of what it was that they told you. You can just hold on to that. And we also have the ability to store actions using our motor patterns. So if you watch someone do something, you can hold a memory of that action in your own mind. Maybe you want to then copy that action yourself, so you can have that as well. And we start seeing errors if we try and store too much information in any one of these sort of forms too quickly. So if somebody gives you a long string of numbers, you might have trouble with that because it's too much information too quickly. But if we're using a couple of numbers and maybe an image and maybe emotion, we can start expanding what we're capable of holding on to. So that's short-term memory, but as I said, we also can talk about working memory. And this is when we have, again, a limited capacity system. We're still going to be storing information, but here we specify that it's specifically in order to manipulate that information, to work on that information. So working memory is a little bit more than the short-term memory we've been talking about. So instead of just holding it, we're doing something with it. So holding information in active memory to work on it. So maybe you're doing mental math. Somebody gives you a couple of numbers and asks you to add them together. That would be using your working memory. If somebody just tells you a bunch of numbers and says, remember these numbers, that's just short-term memory. And the sort of restrictions on our working memory is pretty much the same, because short-term and working memory are all under that same umbrella of immediate memory. So, but a 20-second duration and about a digit span of 7 plus or minus 2. So all that information is still the same. But when we're talking about our working memory, we can actually go into sort of a little bit more detail on what processes are happening. So we have 4 distinct parts that we can talk about. And this model is sort of one of the most widely used. There are lots of different models of working memory. And even this one has been recently updated. The episodic buffer wasn't always part of this model, but I find it to be fairly useful. And so here we focus on our central executive. So this is the part of the brain that's going to be focusing our attention, that's going to be handing out roles to the rest of our working memory systems. So this is the part of the brain that kind of keeps track of what we're doing, what we need to do it, and where information is at any given time. We can then have our phonological loop. So this is our inner voice. This is maybe somebody is giving you directions. That's a great example for working memory. And so they told you what to do. So your inner voice could be you repeating those steps. So that could be your sort of memory of what was just told to you. We would also want to tie in our episodic buffer. So we've talked about episodicness as sort of events or order to things. So when we're doing directions, knowing what order things happen in is very important. If they tell you to take a right and then a left, that is very different than taking a left and then a right. So our episodic buffer keeps things in order. And then our visuospatial sketchpad would be our inner eye. So maybe we imagine what we would see when we turn left or right. And so we can use all of these different parts of our sort of internal brain things in order to have our working memory sort of follow these instructions, work with that information, and get to the place you're trying to get to. And during this process, each of these different parts can actually pull on our long-term memories. So if somebody tells you to turn right at a particular street, maybe you know where that street is, so that can activate that part of your long-term memory, and you go, oh yeah, I know what that looks like. This is what I'm looking for now when I'm following these directions. So your visuospatial sketchpad could pull up a mental image of what that corner looks like. Or maybe you forgot part of the direction, so you want to sort of think back about, okay, what were they saying at these particular stages? So we can kind of use all of these different sort of interconnected pieces to function and do something with our working memory. And so that's kind of that area over there with the encoding and retrieval, where we can put things into and pull things out of our long-term memory in order to work with that information while we're trying to function. All right. And so that's kind of a nice way to transition over into, okay, so long-term memory. We can put information into it and pull it out of it, but what is it and how do we do that? So long-term memory could be considered our library of memories. It's sort of a durable storage of all of our past events and things that we've learned. There's a lot of debate on what the capacity is of our long-term memory. So you'll see estimates from somewhere to fairly large. I've seen some texts talk about it being like 500 hours of high-definition video recording. Or some people can argue that it's unlimited. So we're saying in the range of very large to infinite is where we expect it to be. And if nothing happens, these memories can endure for a lifetime. So people who are hundreds of years or 100 years old can have memories that span a century. So we will talk about some cases where people lose memories and what kind of leads to that. But if left to its own devices, it's a pretty large storage that lasts for quite a long time. And we've talked about how unreliable some of those memories can be, but it's still pretty remarkable how much we can store. And so in this sort of getting started on transferring information to long-term memory, we can actually kind of explain a concept that we talked about before the break. So we had talked about rehearsal, so just plain old simple rehearsal where you repeat back whatever it is that you're trying to remember. And we had also mentioned elaborative rehearsal, where you add information to it to make something easier to hold on to. And I was talking about a grocery list. So you need eggs and milk and bread. So if I was talking about elaborative rehearsal would be, instead of just saying, okay, eggs, milk, bread, what if you said, okay, eggs and milk because I want to make a cake, and bread because I need toast in the morning. So you're starting to draw on other things. So every morning I have toast. I no longer have bread, so I need bread so I can have toast in the morning. And I bought a cake mix but didn't get eggs or milk, so that's sitting on my counter and I need to make it. So by pulling on other resources, by elaborating on what we're doing right now, we can actually have more effective memory because we kind of blur the area between our immediate memory and our long-term memory. So we get to this point where, okay, I'm not just remembering this list, I'm remembering how it interacts with other factors. So we do a little bit of encoding and a little bit of retrieving, and by activating more systems, we actually start sort of meaningfully connecting all of these ideas, and it makes it a lot easier to remember. And I believe I've said this before, but we're going to find over and over again with memory that the more systems that you can activate, the better your recall is going to be. All right, so how else can we enrich encoding? Following along that rule of more systems is better, we can talk specifically about elaboration, which we just did, where we link a stimulus to other information while we're encoding it. So instead of just trying to remember a grocery list, what if you're trying to study for a test? So what if you're trying to remember the process of memory? Maybe you can think of some examples. We've made comparisons with computers and how they store information away and how we retrieve information from the hard drive. That is an elaboration where it's not just the model of memory, it's now connecting it to something that you have experience with. So it makes it a little bit easier to remember. we can also use visual imagery. So if you create visual images to represent the words that you need to remember, that can help you out. There's a little bit of a caveat here where this only really works for concrete objects. It's a little bit harder to visualize information, sort of saving to a hard drive and coming back from it. So maybe you would think of a cartoon of sort of ones and zeros moving through space or something like that. But sort of less concrete objects are harder to visualize. It'd be a lot easier if I was thinking of my grocery list and I think of bottle of milk and a pack of eggs and a loaf of bread. That's pretty easy to visualize. And then we also have that this idea of the dual coding theory. So this tells us that if we can form semantic or visual codes at once, sort of both together, that's going to help us perform better. So again, back to that idea of not just one or the other system, we want both. So having multiple systems active makes it easier to remember. And then our last point is self-referent encoding. And this is when you make the information personally meaningful. So if you are coming up with examples, so maybe you're not a computer person. Maybe thinking of memory in terms of a computer is awful because you are not tech savvy. So maybe you want to come up with a different example. Maybe you want to think of it like a cupboard. And you're going to put things in there for storage and take them out later. Maybe that makes more sense to you, so you can encode the information in something that has meaning to you. And so maybe you visualize your own cupboards and yourself putting things in and taking things out of that cupboard, and that helps you store those memories a little bit better. So a bunch of different techniques to help you sort of connect with that information, activate more systems, and end up pulling that information a lot better. And so we can also talk about our levels of processing. And this is going to be on the same idea of the more systems you get involved, the better you do. But this is looking at it specifically, especially how we test things like lists of words. You're going to find that a lot of the memory research, especially in psychology, focuses in on how we remember words. So they'll give you a list of 10 words or 100 words, and they'll see how you perform on recall tasks based on different factors. So if we vary our level of processing, so if you're given that list and you're asked to consider the words on that list with different kinds of questions, we can see that your performance can be enhanced or not, depending on what we're asking you to do. So if we start at our shallow processing at the top there, we have structural encoding. So this would be an emphasis on the physical structure of the stimulus. Basically, they get you to read a word and answer a question like, is it written in capital letters? Is the text black or white? Is it, or does it have the letter C in it? Something about the structure of the word, what it looks like, but nothing about the meaning or what it sort of does. So that's sort of shallow processing because we're not really getting at anything other than what the word looks like. Our next step down would be intermediate processing. So this would be things like phonemic encoding. So we start focusing in on what the word sounds like. So does it rhyme with wait? Does it end with this sound? Does it start with that sound? So that's sort of getting you to start thinking about the structure of the word itself, but also in how it would sound. But again, not the meaning of the word. That comes in for our deep processing. So this is the most intensive type of processing. This would be like semantic encoding. And again, semantic just means meaning. So we would emphasize the meaning of that word. So they would ask you, does the word fit in this sentence? So then you have to understand what the word means and how it relates to other things. And so from this idea that more processing, more systems involved is going to be a good thing, we see that the results of tests like this kind of line up with what we would expect. So if we look at words recognized, so basically they'd give you sort of a list of 100 words, they'd ask you questions about all of those. either using structural encoding or the phonemic or the semantic encoding. And then they would see how many of them you correctly identified. So this here is, okay, if we gave you then a list and said which ones were you shown previously, that's recognition. They might also ask you for straight recall or a whole bunch of other variants of that. But we always see this sort of nice positive relationship where deeper encoding leads to better performance. So depth of processing is going to help us encode better and then leads to better recall later. And before we go too much further, we should also talk about the fact that we have different types of long-term memory. Again, we've been talking about things in terms of sort of general memories of things, but we can actually divide them up into different categories, and we can start seeing that each category doesn't necessarily get stored or processed or treated the same way. So the first section, we're actually going to look at the top two, and those fall under the concept of declarative memory, things that you can explicitly talk about. So we have examples of episodic memory, so memories whose contents pertain to specific events or episodes from your life. So if you remember going on a trip as a child, that is an episodic memory. And you can talk about going on a trip as a child, which is why we would call it declarative or explicit, because you can talk about it, you can describe it. Semantic memory is going to be memories whose contents relate to specific facts and pieces of meaningful information that are not based on personal experience. So this is information that you know, but isn't specifically related to your particular experiences. So if you're talking about what's the capital of Canada, or what street is this particular building on, those would be semantic memories. And again, still declarative, still explicit, because we can talk about knowing these bits of information. When we have exams, we're testing your semantic memory, your memory for facts. And so we can actually talk about a little bit of a bleed between the two of these. So if we were getting you to think of, I use the example of the capital of Canada. So you can probably tell me that the capital of Canada is Ottawa. So that would be a semantic memory. But maybe you're one of those people with a really good memory and you remember the first time you learned that fact. You were sitting in a geography class, probably in grade 4 or something. And you remember which desk you were sitting in and which teacher told you. So that would be an episodic memory because you're remembering a particular moment in your own life. So you're remembering the point when you learned something that would become a semantic memory, but if you're focusing on the event, the episode where it happened, then it's episodic. If we're just caring about the factual knowledge, then it's semantic. So that's how we sort of separate the two. Yes. Okay, so declarative, there's those two there. Then we have procedural memory, and this is non-declarative memory, or implicit. And the reason is because procedural memory is memories that pertain to how you do things. So if you know how to ride a bike, that's part of your procedural memory. You can't necessarily describe every single aspect of riding a bike. It's really hard to explain everything that goes on, but you can sit there and do it. That's perfectly fine, which is why we call it implicit. It's something that you can do internally, but you can't necessarily tell someone else how to do it in sort of easy terms. And procedural memory is actually going to be stored slightly differently than our explicit or declarative memories. So we've talked about parts of the brain that are active in different parts of daily behaviors. So if you remember our cerebellum, sort of at the base of our skull, that would be involved in a lot of movements and remembering how to do things, like riding a bike. So there's a lot of evidence that our procedural memory involves the cerebellum at some level or another. And this kind of a question of, okay, well, we have these 3 categories of memory, and we've divided them up in what might seem like fairly arbitrary ways, but are they actually distinctive systems? And we could even go further. Okay, so these are all types of long-term memory. Are we even sure that long-term memory and short-term memory are separate systems? And the answer is, we have evidence that can say yes or no. So most people will say that yes, short and long-term memory are distinctive. So we have our sort of sensory memory, and we have our immediate memory, and then we have our long-term memory, and they're three separate systems. There is some evidence that short-term or immediate memory does fall under long-term memory because they're very closely related. As we were seeing with our working memory, where you can pull information out of storage and put it back into storage fairly quickly, there's a lot of crossover there. So some models of memory will just include short-term and working memory as part of long-term memory. And we're actually going to look at a couple examples of situations why we think that. But for all of these questions, all of this, what is separate and what is not separate, this is where our case studies come in handy. And within psychology, we've talked about case studies as this sort of special instance where something strange has happened to a specific individual, and because of whatever damage they have suffered, we're able to determine how it impacts their functioning. And so we have a couple of very key figures in memory that we can look at in terms of sort of what they've taught us about these different systems. So do they show us that short and long-term memory are the same or different? Do they show us that procedural and declarative memories are the same or different? And so on. So we're going to look at a couple of those. But before I go too much further, I do want to point out two terms that are going to be fairly important when talking about memory studies. And these are the terms of anterograde and retrograde amnesia. So amnesia is just that sort of inability to remember things. And when we specify that it's anterograde or retrograde, we're talking about the directionality of that forgetting. So anterograde amnesia is loss of the ability to assimilate or retain new knowledge. So I have a couple of movie examples. So maybe you've seen the movie Memento, where he can't form new memories. So as soon as something leaves his short-term memory, he forgets it entirely. So if he wants to remember something, he has to write it down. And if you're sort of somebody who likes roots of words, if you think of an anterograde orbit, that's something that's orbiting just ahead. I don't know that that one's actually helpful. I usually remember the retro one, and then the anterograde is the opposite. But retrograde amnesia is loss for events that happened in the past. So you forget things in the past. And I just use the retro meaning old. But usually these are going to be centered around a particular event. So people with anterograde amnesia would be able to form no new memories after experiencing a trauma. And then retrograde amnesia would mean that they forget everything prior to that trauma. So there's usually sort of a defining point. There's a little bit of fuzziness on either side. And these can be short-term or long-term effects of this, not in terms of like short-term memory and long-term memory, I guess, more of a, it can be something that is a permanent problem, or it might be something that goes away as the brain damage heals. And in our case studies, we're going to look at individuals who forgot and forget for basically permanently, because they cannot recover from what they have suffered. Okay, so I forgot to include these slides on your slides. I will be putting them up after class, but we do have some time still, so I'm going to keep going, and then I will give you these slides later. So don't worry about writing this all down. I will give you the slides, but I found that my other class was a little bit short, so I wanted to keep on keeping on. So we're going to look at 3 distinct case studies, and if you've studied memory anywhere else, you've probably heard all 3 of these. These are pretty big case studies. But the first of these is Clive Wearing, and I always remember him actually because he is one of the few people who doesn't have sort of letters associated with his name. So it's just Clive Wearing, whereas most other people would just be referred to like CW, as we'll see in the other ones. But Clive Wearing was or I guess is, I'm not sure if he's still alive or not, a British musician and composer. So he ended up having a virus, and it attacked his central nervous system and specifically caused damage to his hippocampus. And this process has led to both anterograde and retrograde amnesia, which means that he can't form new memories, and he also can't remember previous memories. So he exists only with his immediate memory. He can't form new memories, he can't recall things, he just exists as he is. And interestingly, we've found that despite this inability to form new memories, he can actually learn new tasks. So if you taught him to do something, usually in these situations, and I think we'll see it in one of the later videos I'm going to show, things like tracing a shape in a mirror. So you can only look in a mirror and you do something backwards. It's really hard to coordinate yourself to do that. But as you practice, you get better at it. But Clive Wearing, despite having severe amnesia and the inability to form and store memories, he would still improve at this task every day when he was asked to do it, because he's using a different kind of memory. And so that's some evidence of procedural memories being stored somewhere else, and being stored in a different way than our declarative memories, which is pretty cool. Yeah, I'm going to do this and then I'll show the video. Okay, so what we get from this really unique information from Clive Wearing, it shows us that our procedural memory and our declarative memory are two different systems. They're stored differently because he has the inability to form any kind of declarative memories, but he can form and use procedural memories. It also tells us that our procedural memory doesn't require the hippocampus, because hippocampal damage didn't interfere with his ability to form those procedural memories. It did, however, interfere with his declarative memories. So that tells us that our hippocampus is really important in forming and retrieving both of our types of declarative memory. So our semantic and episodic long-term memories probably have something to do with the hippocampus, because when there's hippocampal damage, the function goes away. So that's really useful information there. And so that's one of our first big studies that said, okay, procedural memory is different than declarative memory, and it's involving different pathways, and it's storing in different ways. Okay, so now I'm going to see if I can figure out how to show the video. All right, and then we can come back to talking about HM. So the video did a great job talking about all of this stuff here. So mentioning that it was a temporal lobectomy, where they removed part of the hippocampus, the amygdala, and some other pieces in that general area. We actually get to see what it looked like here, so you can see which structures were missing. And this lines up with what we had just seen with Clive Wearing, because they removed that part of the brain that was damaged in Clive Wearing's brain. And so we got to see, yeah, okay, so this leads to difficulty forming new memories, but also some difficulty retrieving memories, depending on which parts are affected. And so we get that conclusion here that our working memory doesn't require those medial temporal structures. We have working memory without a hippocampus. That's fine. And so that says, yeah, short-term and working memory are no, that should be long-term. Sort of our working memory / short-term memory and our long-term memory are different systems, and that the structures that were removed are important in that process of encoding memories for long-term storage. So HM and Clive Wearing sort of have that really nice, consistent result between them, showing us the importance of our hippocampus there. Our last case study that we should just have enough time to finish is KF. And unlike the others, we don't actually know their full name. I have spent a lot of time trying to figure this out, and there's a lot of conflicting information. But KF was an individual who suffered damage to their left parietal occipital region, so that sort of red spot on the brain there, after a motorcycle accident. And we know that the left parietal is really important for things like language and performing mathematics. And we found that with KF, after suffering this damage, they had issues with short-term memory. So with our digit span conversations earlier, most people have a digit span of 7 plus or minus 2. KF had a digit span of just 2. And sometimes, if there was enough going on, sometimes they could only remember a single digit. So this showed us that, okay, that part of the brain, sort of that outer structure, seems to be what's involved in our short-term or immediate memory. And it interestingly showed us that their long-term memory wasn't impacted here. So despite the fact that their short-term memory was sort of damaged and could no longer form sort of hold on to information long enough to do anything with it, they were still forming long-term memories. So this actually goes against the model that we've been using so far, sort of our 3-factor model, or 3-component model, or whatever we want to call it, because we have this idea that we go from sensory memory to short-term / long or working memory or immediate memory, and then we go over to our long-term memory. But here we're saying, okay, so short-term memory is damaged, but we can still make long-term memories. So this is one of those pieces that gives us some evidence that, okay, well, maybe short-term memory isn't a distinctive on its own component. Maybe it's slightly different. So this gives us the idea that, okay, well, maybe we can still form long-term memories, even if we don't have that ability to form short-term memories. So maybe it's a different system. Maybe it goes around. We're not quite sure. So this is basically that big sort of problem that we run into that goes against a system that works pretty much consistently for everything else. So, yeah, so that's an interesting one to consider and a good spot to end up here. So we can leave it there, and we'll continue talking about sort of how we encode memories and retrieve memories next time. But yeah, some interesting stuff to talk about.